All right, test 5 review. Number 1, what is the slope of the graph y equals negative 7x plus 23? Should be a very easy question. Your slope is when it's in slope-intercept form, so as long as it's solved for y, your slope is what is the coefficient of x, so negative 7 or negative 7 over 1. If you wrote it as a fraction. Number 2, Coach Melton spends an afternoon at Topgolf. He's playing from the platform 9 3/4, which is 15 feet off the ground. That's his best shot, where x represents the horizontal distance of the ball and f of x represents the vertical height. What is the domain for his best shot? I'm gonna graph this on Desmos to help us see it. But as we look, just remember, keep in mind we're looking for the domain, so we're looking for the possible x values. So negative 0.05x squared plus 21x plus 15. All right, if we zoom out, quite the golf shot, we can see that it's saying that x is modeled by the time he hit his shot. So if I can kind of adjust it here, I can see he hits his shot there at about 15 feet off the ground. It goes up there to the vertex, and then it hits the ground right there. And it takes 420.7 seconds for it to hit the ground. Oh no, that's not the time, I'm sorry. X is the horizontal distance. So the horizontal distance it goes is to 420 feet. So 420.7 feet. So the domain, we could say the lowest x value is 0 and the highest is 420.7, somewhere around there, if you rounded it to 1 decimal place. All right, next, number 3. Erase that. Which value of x makes the equation true? All it's asking us to do is just to solve it. It's just a fancy way of wording that. So what I'm going to do is I'm going to distribute that 2.75. And I'm going to get 8.25x plus 7 times 2.75 is 19.25. Now I'm going to isolate the x, so I'm going to do minus 19.25. So negative 5.5 minus 19.25 should be negative 24.75. Yep. I'm going to bring down what's left over here. So it's really just solving an equation, but we have decimals involved. But you got a calculator, so don't let that spook you. We'll divide by 8.25. Divide by 8.25. I believe we should get negative 3. I'm going to double check that. So negative 24.75 divided by 8.25. And we do get x equals negative 3. Number 4, factor that. I'm going to erase the work from the question up above. The way I factor is I write the a, b, and c values. Step 1, I'm going to do a times c and get negative 28. I make a t-chart and I'll list all the factors of negative 28. So I've got negative 1 and 28, negative 2 and 14, negative 4 and 7. And I could reverse those negatives if I needed to, which would be like positive 1 times negative 28 and so on. But I'm going to look at these and see which of these factors combine and add to the b value. Well, it's negative 4 and 7. Then if we use that, you can draw a box. You don't necessarily have to since the a value is 1, but go ahead and do it. Put the first term in the top left, last term in the bottom right. Split the 3x using negative 4x and 7x, those two terms I have circled. At the end of each row in each column, I'm going to take out the GCF. So I have x, I have negative 4. I use negative 4 because it's bordering a negative number. Top column, I've got x. Top right column, I've got 7. So our factored form would be x minus 4 times x plus 7. If Multiply x minus 4 and x plus 7, I'm going to get back to my original x squared plus 3x minus 28. Number 5, we got the table, the linear, so it's a linear relationship between the average height in feet of trees on a farm and the number of years since the trees were planted. What is the rate of change of the average height in feet of trees with respect to the number of years? So it's just wondering, like, what's our change, our average height change, so our change in our y value, that's plus 14, divided by our change in our x value, which is plus 2. And I know it's going to be consistent the whole way because, like I underlined there at the beginning, it's a linear relationship. So our average rate of change is going to be the change in y over the change in x, so 14 over 2, which is 7, or 7 feet per 1 year. What is the equation and slope-intercept form of a line that passes through those points? All right. So slope-intercept form, y equals mx plus b. I'm going to fill in the m and fill in the b. All right, filling in the m, the slope. I've got 2 points, so I could use the slope formula. I'm going to label my points x1 and y1, x2 and y2, and I'm going to get negative 4 minus 0 divided by negative 8 minus 1. I'm going to get negative 4 on top, negative 9 on bottom. I'm going to go ahead and write that as a positive since it's a negative divided by a negative. And that's as simplified as that slope can get. All right, the second part, I need to fill in the y-intercept. Fill in that y-intercept. So doing that, it's going to be a little bit trickier, but I know that that is when x equals 0. So one way we could do this, I'm going to fill in, I'll circle this first point there. I'm going to circle that point. I want to fill those points in for x and y. So I'm replacing the y with a 0. I know the slope is 4 over 9, and I know the x value on this point is 1. I don't know the y-intercept. So I can just use a little bit of algebra and figure out the y-intercept. So 4 over 9 times 1 is 4 over 9. Subtract that, and I know that the y-intercept is negative 4 over 9. So filling all that in, and I could have used either point. I should get the same answer for either point. So I could have used the point over there, the negative 8, negative 4. I would have gotten the same answer. Filling all that in together, I'm going to write this out. I don't have a ton of space. Let's write it in blue. Y equals, my slope is positive 4 over 9. It's multiplying the x. The y-intercept is negative 4 over 9. That's how that looks right there. Number 7, graph that. So what I'm going to do is I'm going to solve this for y. I'm going to divide by negative 9. That way I can get it in slope-intercept form. I'm going to get y equals 12 over negative 9x. 45 divided by negative 9 is negative 5. I'm going to go ahead and simplify that and get y equals, what would that be, negative 4 over 3x minus 5. All right, let's graph it here. I'm going to erase the work up above. I'm going to just kind of sketch a graph. I know that the y-intercept is negative 5. That's going to be my first point. I'm just going to make 2 points on here. So I'm going to start at negative 5 for the y-intercept. My slope is negative 4 over 3. So the way I have it, I could go down 4 and right 3, but I really don't have enough room on what I've sketched here. So I'm using that slope to create another point. So instead of going down and right, I could go up 4, 2, 3, 4, and left 3. It's the same direction. Connect those dots, and that is how the line would look. A sandwich artist determined the annual profit in dollars from selling sandwiches using that function where n is the number of sandwiches sold. What is the annual profit if the sandwich artist sells 750 sandwiches? couple ways you could do it. You could type this function into Desmos and then click the table and put 750 for your input. Or you could use a calculator and just replace the n with a 750. You should get the same thing either way. So whichever one you think would be easier. But just understand that we are replacing the n, the variable, with a 750. So we get 4, 750 minus 0.02, 750 squared. And you should get 18,750. And that represents the annual profit when they sell 750 sandwiches. All right, next page. We got the exponential function. Which function is best represented by the graph? All right, just looking at those answer choices, I know for sure I can eliminate one of them because this is an exponential function, and if I look at C, that's linear. So I know it's not C. No, it's not C. All right, a little bit more problem solving. If I look left to right, if I start left and I go to the right, that function is decreasing. It's going down. So I know it's exponential decay. If I look at A, that's exponential decay, and B is also exponential decay. However, D is exponential growth. So I can also eliminate D. All right, my other thing, I'm going to look at the asymptote. The asymptote's that invisible boundary that the curve's going to approach. So if I look here, that this exponential curve is the asymptote. It's approaching 0. It's not moved up or down. So there's not anything adding or subtracting at the end. So that also lets me eliminate answer choice A, because the asymptote A would have an asymptote of 4. And I know that that's not the case because it goes way below 4. So no, it's not A. Also, 4 makes sense because that number out front is your y-intercept. And we can see it does have a y-intercept of positive 4. So B. 10. A student worked out at a gym continuously for 50 minutes. The graph shows the remaining percentage of the workout as a linear function of x, the time. Describe the domain and range of this function. So the domain, the amount of time, that's our x, is the amount of time he's working out in minutes, or she, the student. The lowest amount would be 0, and the highest would be 50. And we could have decimals. We could look at 7.4 minutes. All of those make sense, anywhere between 0 and 50. Our range, our y values, is the percent of the workout they have remaining. So again, we're going to go lowest to highest. The lowest amount is 0. The highest amount is 100. And we could have decimals again. We could have 40.3% of our workout remaining. There's nothing that makes that have to be whole numbers. 11. The graph of the quadratic parent function is transformed to create that. Says it's quadratic, so it's missing a squared. Should have that. My bad. Describe the transformation that took place to form the graph of g of x. All right, first transformation, the minus 6. When you subtract directly to that variable, that is the opposite. It's like a mirror in your house. It's moving it right 6. The second part, the plus 3 at the end, is moving it up 3. So it's moving it right 6 and up 3. 12. What is the positive solution to this equation? A couple ways you could do it. You could solve it, or it's, I think, the easier way to do it. It's asking for the solution. That's the x-intercept. Let's type it in Desmos. 15x squared equals 60. All right. We've got two solutions, -2 and +2. It just says, what is the positive solution? So +2. 13. An 18-wheeler is used to haul 25-pound boxes of clothes and 70-pound boxes of school supplies. No more than 12,000 pounds of boxes can be hauled by the truck. Write an inequality. It represents all possible combinations of x, the number of boxes of clothes hauled, and y, the number of boxes of school supplies hauled. Um, so this question was designed to throw you off to have a number there, 18 wheeler. We don't use the number 18 at all. So we're looking at 25-pound boxes of clothes. So X is the clothes. So we can have 25 pounds boxes of clothes. Plus we can have 70-pound boxes of school supplies. That'd be 70Y. Tells us Y is the number of boxes of school supplies. They can't haul more than 12,000. So that weight altogether, that right there, has to be less than or equal to 12,000. That's it. 14, simplify that. So we are adding, when we're adding polynomials, we just combine like terms. So I'm looking at, there's my x squareds. I got 6x squareds when I combine those. My next variable is x, so I've got 6x. And 24 plus negative 21 is 3. That's it. A bank account earning an annual compound interest was open. No additional deposits or withdrawals. The balance after X years can be modeled by that. Which statement is the best interpretation of the values in the function? The initial balance of the account decreases at a rate. So if I look, that tells me it's growth. So I know it doesn't decrease. A doesn't make sense. The balance in the account increases at a rate of 7.5% each year. That kind of makes sense. Let's keep going on though. The initial balance was $1,075. The initial balance is that number out front. Our initial balance was 1,200. The balance in the account at the end of 1 year is 1,200. Well, if you plug in a 1 for X, you'll see that it's not 1,200. It's actually a little bit more. The initial balance was 1,200. At the end of 1 year, it's earned some money and it's greater than 1,200. But yeah, the account is increasing at 7.5%. Remember that growth and decay rate? So if we look at this, if we take away 1, we can see we have that. If we change that to a percentage by multiplying by 100, we can see that's a 7.5% growth rate. In August of 2016, Instagram launched the abilities for users to add stories. The table shows the number of Instagram stories posted in billions over time. The data can be modeled by a quadratic function. Which function best models the data? So, again, we're going to use process of elimination and make this a little bit easier. It tells us some information here. It says the data can be modeled by a quadratic function. If it's modeled by a quadratic function, it could be A because we have that variable squared. B is not quadratic. B is linear. So I know it's not B. C, that variable is in the exponent. That's an exponential function. It's not C. D, D does have a squared in the exponent. So it could be D. But I've eliminated 2 answers here and made this even a little bit easier. A couple things we could do. You could take numbers. So I could substitute and replace the T with a 5 and see which one gives me 1.25. You could do that. I'm going to type in answer choice A in Desmos, and we'll look at it this way. So I'm going to type in 0.05. We have to use X instead of T. Minus 0.7 X plus 3.5. What I'm going to do is I'm going to hit the settings. I'm going to hit that table, and I'm going to type in some of the numbers from the table here. So I'm going to replace this. It starts with a 5 on my paper, and then a 10, and then a 15. And you can see that these numbers are all matching up. That's because those functions, that's table represents that function. So that's one way you can use that to check. I'll just show you if you typed in, if we did the same thing for answer choice D, let's look in, I just want to show you how it looks. Ta-da, table. If I do the same thing, if I replace that with a 5 and then a 10, so you can see that those outputs aren't matching the tables on the paper. That's how you can use that. A is correct. Write the equation for the linear function in point-slope form. So point-slope form is on the formula sheet. There's lots of different answers you could have here, but really, one thing that does have to be consistent is the slope. This is what point-slope form looks like on the formula sheet. You can use any point on the line, and you also need the slope. So let's use, I don't know, let's use 1 comma 4 as our point. So all I'm going to do is I'm going to fill that in for x and y. So y is 4. Slope I didn't do yet. X is 1. Let's calculate the slope. To find the slope, I'm just going to do the rise over run between 2 points. So I go down 2, right 1, rise is down 2, run is positive 1. So my slope, the rise over the run, is negative 2. So I would use that for the slope. It just wants it in point slope form, the way that that's written. So that's all you would have to put. If it asks you to put it in slope intercept form, you could distribute and simplify, but that's all it wants. Next page. All right. I gotta give a shout out to Sully for his birthday today. So happy birthday, Sully. Hope you found it to this part. Basketball players scored some shots worth 2 points and some shots worth 3 points. Players scored a total of 77 points after making 30 shots. How many 3-point shots did he make? All right, this is a good question. So what we're going to do is I'm going to say, some shots are worth 2 points, some shots are worth 3 points. I know that they scored, when I'm looking at the points, they scored a total of 77 points. And then if I'm looking at just their shots, how many shots they made 30 shots, not including how many points, whatever one's worth. So that's a system of equations. So we've got that right there. So I'm going to say x is equal to the 2-point shots, and y is equal to the number of 3-point shots. So what I'm going to do is I'm going to type that in Desmos. So it's 2x plus 3y equals 77, and then x plus y equals 30. All right, I'm going to find where those two lines meet. So 13 comma 17, what that tells me, x is 13 and y is 17, that this basketball player made 13 2-point shots and 17 3-point shots. And so the question was how many 3-point shots? 17. 19, the graph of linear function f of f passes through that point and has a slope of 4. What is the 0 of f? Ooh, okay, so it wants to know the x-intercept. A couple ways you could do it. You could use, let's do this. Let's use the point slope form, like on the question just a little bit ago. Point slope form, if you weren't on that question with me just a minute ago. That is point slope form. If you know the slope and a point, you can fill that in for any straight line. It's a linear function. So what I'm going to do is I'm going to do y minus 11 equals the slope, which is 4, times x minus negative 5. I'm just going to go ahead and write plus 5 because it was minus, and then the x1 is negative 5. I'm going to type that in Desmos. Y minus 11 equals 4 parentheses x plus 5. Okay, so once you type it in Desmos, if you know what you're looking for, there's our x-intercept. That's all it was asking for, was the 0. So negative 7.75. That's probably the most efficient way to do that. There's a lot of other ways you could have done it, but that's kind of what I would do. That's my advice. All right, a system of equations is graphed on the grid. Write a system of linear equations in slope-intercept form that matches the one above. Okay, so I think it's just wanting to like think the question on the test like gives lines and is having you match up the lines with the graphs. So let's do the red line. I'll do it in red mark or red pen here. I want it in slope-intercept form, so I'm gonna do y equals. I know that the slope is up 2 over 1 because I'm just counting rise over run. So 2x, and then the y-intercept is positive 5. So that would be one equation. The blue line I'll do in blue. Y equals, the slope is down 1, right 2, so negative 1/2 x. The y-intercept is negative 2. There you go. 21. The table represents some points on the graph of an exponential function. Right, there's a keyword. Which function represents the same relationship? So if I glance at the answer choices, all of those are exponential. So I can't eliminate anything just by knowing it's exponential. What I can do, again, I'm going to use Desmos. I'm going to do my tool. I'm going to add a table. So if you click that plus button in the top left and click table, I'm going to type in -1, 12, 0, 14, 1. I'll do a 16.3333 like it says there, and 2, 19.0556. All right, what I'm going to do is I'm going to type each one of these in and see which one matches those dots. So here I'm doing 12 parentheses 2.3 to the power of x. I can see that A doesn't go through all those dots, so I know it's not A. We'll type in B, 2 to the power of x plus 14, not B. C, uh-oh, I accidentally erased one. C, 14 parentheses 7 divided by 6 to the power of x. It looks like it's probably C. I'm going to type in D just to double check. 12 parentheses 4 divided by 3, close parentheses, to the power of x plus 2. And you can tell it also wasn't D. So yeah, C. Again, I just added the table, put that table in there, and then matched up the equation to see which one went through all those points. Next page. 22. Write a linear function that models the table. All right, so if I was to do a linear function, let's make it y equals mx plus b. I can see it's in function notation, which is fine. But if I look at my slope, so my slope is going to be my rate of change. My change in my y value, which is -6, divided by my change in my x value. -6 divided by my x value, which on this is +2. So make sure you're consistent in what you're using. If I'm using the first two on the y, make sure you use the first two on the x. So going from 3 to 1 was +2. So my slope is -3. Okay, so I could say -3. Instead of x, I can see that the input there is n, so I'm going to put n. At the other part, the y-intercept, so that part right there. What I'm going to do is, it is when your y-intercept is when x, which I'm going to put like quotes around, is 0. X is really just our input. So we're not using x here, we're using n. So if I can think about when n is 0, well, I know when n is 1. If I go backwards 1, that would be 24. I just used my slope to go backwards. That's how you would do that. So there's other ways you could have done it. You could have done it like the prior ones where you put in a point and solve for the y-intercept. But if the table is like right there, if you just need to go backwards 1, instead of going -3, because our slope is -3, if we just need to go backwards the other way 1, let's go +3. I know it's going to be 24. All right, the graph of f of x equals x squared was transformed to create the graph of g of x, which is equal to f of x plus 5. Describe the transformation. So it really just wants to know, we had the original f of x, g of x is equal to the same thing as f of x, but adding 5 at the end. How does that transform it? Well, adding 5 at the end Just moves it up 5. Graph of linear function k passes through those points. All right, I'm going to circle linear because that's important. Answer each of the following. What is the slope of line k? All right, let's do slope formula, x1, y1, x2, y2. So we get 8 minus 0. If you don't remember, I forget that some of y'all go out of order on these videos, which is fine. Your slope formula is y2 minus y1 over x2 minus x1. It's on the formula sheet. So 8 minus 0 over 3 minus negative 9. I'm going to erase the slope formula so I have room. So I get on top, I get 8. On bottom, 3 minus negative 9 is 12. I'm going to simplify that and get 2 over 3. What is the 0 of k? The 0 is the x-intercept. So when y is 0, I can see that the 0, the point, it's there. So it's negative 9. What is the y-intercept? That one's not as easy. I'm going to have to do a little bit of work. Let's do it like this. I'm going to erase the slope up there. All right, what I'm going to do is I'm going to do choose point slope formula. I know a point and I know the slope. So point slope formula again is that right there. It's on the formula sheet. If you know a point and a slope, you can use that to write the equation for the whole line. So I'm going to fill in, let's just do this first point I already have. Y minus y1, which is 0. The slope I already figured out was 2 over 3. X minus x1, so x minus negative 9 is that. Let's simplify this. The 0 doesn't change anything. I'm going to distribute the 2/3. 2/3 times 9 is 6. So that, I'm able to see the y-intercept is 6. List 2 additional points. Well, I know that the y-intercept is 6, so I know 0 is 6, an additional point. Really, you could type this in Desmos and get lots of points. 2 over 3 x plus 6. You can hit this table here. You can see lots of points here. You could write down, I mean, there's lots and lots of different answers. But whatever you want to write down there, understanding that those points make that line true. 25. What is the x value in the solution to the system of equations? So the way it's set up, you could use substitution, but I mean, you could also use Desmos, and I'm going to do that because I know it's going to be right as long as I can type it in here correctly. So I've got negative 2x plus 3y equals 15. And on the next line, y equals negative 2x plus 5. So the solution would be 0, 5. Oh, it asks for the x value. So the solution is 0, 5. That's the point they have in common. The x value of the solution is 0, so your answer would just be 0. The table shows a linear relationship. I'm going to underline that keyword or circle it. It's linear. I know it's a constant rate of change. So what is the rate of change of y with respect to x? So it's just asking for the average rate of change. So I'm going to find the change in the y value. From 346 to 244, how is it changing? If that's a tough one for you, that's okay. In a calculator, I would type in 244 minus 346. That tells me it's going down 102. I get negative 102. And that makes sense. I start at 346, I'm going to 244. I should get a negative number because it's going down. The change in the x value, negative 18 to negative 12, is plus 6. So the change in y with respect to x is negative 102 over 6, which simplifies to negative 17. List the solution or solutions for number 27. Let's do this. Let's just type it in Desmos. Understanding what it's asking for when it's asking for the solutions, just asking for the x-intercepts. You could type it in like that. If you put the equals 0, that's fine. It's just going to give you 2 vertical lines that are the x-intercepts, which is fine. So -2 and +3. Butterfly brackets since it's a list, not a point. Describe the transformation of x squared to that. If you wanted to, you could type it in Desmos and see how it's changed. I'm going to break it down like color-coded one by one for you. So that 4 out front, that is a vertical stretch of 4 units. I'll use a different color. The -6 inside with that x moves it right 6. And the +9 out at the end moves it up 9. Next page. Graph of the quadratic function is shown. Oh, last page. So I know it's quadratic. I can see it's quadratic. List the roots, or root. The vertex is on the x-intercept, so our root is just x equals -3. Or if it was written as a point, -3, 0. List the coordinates of the y-intercept. That's where it crosses the y-axis. This one, I think it's 9. If I'm, it's not super. Yeah, it's 9. So the coordinates of the y-intercept would be 0, 9. What is the equation of the axis of symmetry? So that's that line that divides it in half. It's the x value of the vertex. So x equals -3. What is the minimum? So the lowest that this line goes, the lowest value would be y equals 0. That's the lowest it goes. Also, I mean, if it might be saying like in regards to the vertex being a minimum. So if it was looking at a point, maybe like that. But yeah. Domain and range for g of x. All right, let's do domain. Let's do range in red. Let's type it in Desmos. 1/2. All right, so my domain, this line is going to have a value, all x values at some point. Any number that's possible is going to be an x value of that line at some point. It goes left and right forever. It looks like it kind of goes straight up because it gets so high, but it's still slowly going left the whole time. Like you can see those x values are changing. So the domain is going to be all real numbers. I'll write the symbol. You could also write -infinity to infinity. You could also write all real numbers, whatever it is you want to do. Range. Something about my lowest y value. How far down does it go? I can see that the lowest y value is at 54. A -13 has nothing to do with the y values. My lowest y value is 54. The highest y value, I mean, it goes up forever. It never stops going up. So 54 to infinity, like that. Or you could say y is greater than or equal to 54. At a theater, a customer paid $34 for 4 drinks and 3 bags of popcorn. At the same theater, a second customer paid $13 less than the first customer. Well, that's an interesting way to put it. For 2 drinks and 2 bags of popcorn. The price of each drink is the same, and the price of each bag of popcorn is the same. Write a system of equations that can be used to find the price in dollars for each drink X and each bag of popcorn Y. All right, so I know that 4 drinks, so 4X, plus 3 bags of popcorn was equal to 34 for the first person. The second person bought 2 drinks and 2 bags of popcorn, and they paid $13 less than the first customer. That means they paid $21. It's just asking us to set it up, so that would be our setup. You could type it in Desmos if you wanted to and find the cost of each one, but it's not asking me for the cost, so that's fine. All right, the 8 times the square root of 124x to the third. All right, let's do that. Your calculators, should do this. I'm gonna go ahead and just break this down though. So doing it this way, 124 we could break down as 31 times 4. Then 31 is prime. 1, 2, 3. I'm just making sure it's prime in my head. 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah. All right. So that's prime. 4 can be broken down as 2 times 2. I'm going to rewrite this as 8 square root of 31 times 2 times 2. If you want to, you could expand out the x to the third if that helps you. Remember, this is a square root, so the index is 2, so that means I'm looking for twins. I've got twins right there. One comes out, the other one's sacrificed. I have twins for the x. One can come out, one's sacrificed. Outside, everything multiplies, so I've got 8 times 2 times x. Whatever's left over inside multiplies. I've got 31x. 8 times 2 is 16. 33. The total distance in miles that a train travels varies directly with the time in hours. The train travels a total distance of 364 miles in 7 hours. How long does it take for the train to travel 572 miles? What I would do is I would find the train's miles per hour. Let's do that. 364 over 7. That gives us 364 divided by 7, 52. So how long is it going to take to go 572 miles? So I know it can go 52 miles in 1 hour. That's what I just found by dividing that. So I'm going to do 572 miles divided by 52 miles per hour. That's going to tell me my total time. 572 divided by 52 is going to give me 11 hours. 34, would the following quadratic function have a minimum or maximum? Without even graphing it, like, I mean, you could graph it in Desmos if you wanted, but I know it's going to look, something like, I don't know, maybe something like, I know it opens up is essentially what I'm trying to get at. Let me make a little bit better parabola. I know it opens up because the a value is positive. Any parabola that opens up always has a minimum, no maximum. So I know for sure it's going to have a minimum because it opens up. It goes up forever. What's the coordinates of the vertex? Well, I guess I do have to type it in Desmos. So 2x squared minus 3x plus 5. And we can see that the vertex is right there at 0, 5. That's the lowest, or no, not 0, 5. That's the y-intercept. Ignore that. 0.75, 3.875. So we'll do that. 0.75, 3.875. 35, last one. The graph of the linear function is shown. What is the rate of change of y with respect to x? So it's just asking for the rate of change in y divided by change in x. So let's see, we'll use the 2 points it's marked here. From there to there, we go up 4.5, because our y value is at 0, we're going to 4.5. So we go up 4.5, so our change in y is 4.5. And then we go over, we start at negative 13.5, we're going all the way to 0, so we're going over 13.5. Simplifying that, you could type it in a calculator and use the fraction to decimal button. You'll see it's 1/3, 1 over 3. So good luck on the test. Again, just watching this doesn't help you. Make sure you can explain it. Make sure if you didn't know how to do it, you watch this explanation, but then also like erase your work or use a blank sheet of paper or slate or whatever and like try it again after having watched it. Make sure you can be able to do each problem and you should do very, very well.